My name is Amir Mustafa, and on behalf of Crescent AusIndia, I would like to welcome you all to this special event for artificial intelligence. AI, it's changing our life and work. So I think it's just good today that we just can learn more about what AI is. Just before I begin, just a few housekeeping items. So the toilet is outside on the right, and fire exit just in case of emergency, it's just on the back here. And if you can please put your mobile phones on silent, it will be good. And to begin, I would just like to call upon Mr. Khan, our president, for the welcome note. Okay.
Good evening, Assalamu alaikum, namaste, ladies and gentlemen. On behalf of Crescent AusIndia, I warmly welcome you all to our seminar on artificial intelligence. Crescent AusIndia, as many of you know, is a not-for-profit organization representing Muslims of Indian origin in Queensland. This seminar is part of an ongoing initiative to promote education and awareness within both the Indian Muslim and the broader Australian and the broader Indian diaspora. The key objectives of Crescent AusIndia is inclusivity, fostering diversity and collaboration, community engagement, encouraging active civic and community participation, advocacy and representation, ensuring our community's voice is heard. As part of our inclusivity and engagement efforts, we organize many social events throughout the year. Our main event in this is the annual Eid dinner, which will be held this year on Saturday, the April 12th. So we would like all of you to join us, and please mark the date. We would love all of you to come and join us. For more details on the Eid dinner or Crescent AusIndia itself, please feel free to ask any of our committee members. There's Arif, Asim, Amir, who you just saw here. So ask any of us and we would be happy to sort of fill you in. We are grateful to our esteemed speakers for the time and expertise, as well as the support we have received from Queensland Muslims Inc, the peak body of Muslim organizations in Queensland, Federation of Indian Communities, FICQ, representing Indian organizations in Queensland, GOPIO Queensland, a branch of GOPIO International, the global organization of Indian diaspora. Wearing my GOPIO Queensland Business Council chairperson hat, I also extend a warm welcome to you all. I would like to have a special mention and welcome to Dr. Preeti Suraj, the president of FICQ. Umesh Chandra is going to join us. He is the executive vice president of GOPIO International. So ladies and gentlemen, without further ado, let's dive into the fascinating world of artificial intelligence. I now invite Crescent AusIndia Secretary Amir to introduce our first speaker, Professor Abdul Sattar, one of the founding members of Crescent AusIndia, a shining light in the emerging field of artificial intelligence. Over to you, Amir.
Thank you. So it is my pleasure to introduce our first speaker, Dr. Sattar. Dr. Sattar is a leading expert in artificial intelligence and computer science, having founded and led the Institute for Integrated and Intelligent Systems at Griffith University. With over 250 research papers, multiple research awards, and a strong history of industrial collaboration, he continues to shape the future of AI through his academic and leadership contributions. Please welcome Professor.
Thank you very much, Amir Saab and Yusuf Saab. It's my great pleasure to come and talk about the things which I profess for last 30, 40 years, what I've been doing in my career. So it won't be the full story. And there is the talk I gave you the few months ago in India. So the slides are exactly the keynote talk on some of the conference. But usually when we go and the general audience is there, I make the 1/3 of the talk is for everybody. Okay? And there is a body of some part too technical and then some highlights. So I will just focus on the one part here. And my aim will be just to let you understand the fundamental aspect of AI. Before I go, I like to thank everybody, and especially I like to thank my wife, because I'm the nervous speaker, so she came to support me here. So thank you, Nasreen. Let me go from here. So last 5-6 years, I call my research lab as AI for Life Laboratory. And the reason is that for last 10 years, my focus was on applying AI, using the AI insights in addressing some of the grand challenges in life sciences. And I will mention a little bit about that. I know there are a lot of health applications. Salim Saab will talk about that. But before we go that, one question I like to pose to you, and don't answer right now, think about it. In this room you are sitting, suppose I give paper and pencil and ask you to write down everything you observe. Okay? And then second question I will be asking, can you reason with those observations? Just think about that. Observing the world and reasoning about those observations. It's very simple. You don't need to be technically skilled. Just think about that. Human ingenuity has a great history, it's an amazing history. Our ancestors, when they come to this earth, how they started a reasoning process. So it goes back to that. And I will come back and talk about that. All right. So my aim will be, this talk has a lot of, I told you that some of my contributions to the field, I will just avoid them and just come on the first talk. So, and when you talk about AI, first you have to know that invention of the modern computing. If you type on Google, you will find who is the founding fathers of modern computing. Anybody knows? We know Microsoft, Bill Gates is and not only on, many computer graduates don't know even, So there are some great mathematicians and great engineers. Two of them are prominent people, which I will tell you later on. But think about that. Who founded this? In 40s. It is not too old. But if you look at the calculations, mathematical, the system, the mechanical system, slide rules, calculators, people used to think that those people who can add number, subtract number, multiply are the smarter people. That was known earlier as well. What is new in modern computing? We can also not only mathematical operation, but we can also do logical operations. Okay, something or this or that true. It was not possible with simple calculators. Okay, so that was the great invention. And then the one mathematician who is especially, I think there are a few others, and one great engineer who developed the first architecture of the computers. And once they come to know about that, not only we can compute things, not only we can add and subtract things, but we can also manipulate, think about true or false things, reasoning, logical reasoning. Then the question came, can we make those machines intelligent in such a way that they can perform the task which human beings usually do? Okay. So in 1956, probably a couple of years when I was born, bunch of people from different disciplines not only computer science did not exist that time as a field. So the mathematician, the logician, John McCarthy, who spent most of his life at Stanford University, Marvin Minsky, he spent most of his time at CMU. Then the mathematician, the Menon's theory about the statistics and probabilities you might have heard, some cognitive science people, some linguistic, economics, So these people gathered together at Dartmouth. They called Dartmouth Conference and summer project. In 1956, they started as a summer project, and there they coined the term artificial intelligence. If you do Google, Wikipedia, you'll find out about that, how the artificial intelligence came into existence. And I was fortunate to know both John McCarthy and Marvin Minsky. Marvin Minsky came to Australia in '96 when I was the local chair for one of the conference, big conference. He gave keynote speak. I think most of them are no longer in this world. But the important thing is the two geniuses, McCarthy and the Minsky, had two different approaches to AI. One comes from the logic background, symbolic logic, and Minsky comes from more cognition and connectionist approach, we call. And the debate was going on for us, and you'll see what came after that. So, first question starts when we talk about making machines intelligent. Obviously, the two questions: do we understand what is intelligence? How do we define intelligence? Think about that. Human behavior reflects the human intelligence, but what is there? And we are looking every day when we wake up around us, and then or in brain, we try to answer questions. And my favorite, the philosopher whom I call the founder of the modern enlightenment, 2,500 or 2,000 plus years, Socrates. And he told a very beautiful thing. People often go and overclaim things. The whole idea is that he says he's intelligent because he knows he does not know anything, So knowing what we do not know is a fundamental aspect of intelligence. Knowing what we do not know is the fundamental aspect of intelligence, one of the aspects of intelligence. Okay. So, what is important once people try to understand and go around their environment? The computers, machines, mechanical machines, they cannot operate in uncertain words, incomplete words. Okay? If you have any mechanical robot, automation industry is very well established. Automation industry, you step by step feed to machine what actions it has to take. Okay, no reasoning. It is a very faithful servant. But when you talk about intelligent agent, the machines should be able to operate in incomplete word, in uncertain word, and unknown situations. And now it is happening. Like when you are sending things on Mars, is unknown. You need machines which have some sort of intelligence. So defining intelligence is the key goal of artificial intelligence. What is intelligence? And my own view will come in the following slide. So the two questions here. AI scientists have been around the world for the last 40, 50 years trying to understand the intelligence and trying to find a language in which they can represent this intelligence. You and me can talk in Hindi, Urdu, English and understand each other, but machines don't understand it. Machines need formal languages. Now, formal languages that is the epistemological part. We call, philosophically speaking, this is the epistemological part. We have to find a symbolic language that is expressive enough that can represent the common knowledge. Okay? And second question, how efficiently we can manipulate those symbols to get some useful things done. That's the reasoning aspect. So like modeling the domain and problem and then answering the questions. So these are the two fundamental things all AI scientists have been doing. No matter what they talk about, data science, machine learning, I will come later on. Okay? Do you agree with me? If you want to make machines intelligent, first you have to understand the intelligence, then represent it. Okay? So the knowledge representation issue. Now, day-to-day life, we know our neighbors, friends, any society. And when we talk about what things we confront, when children grow up, the toddlers, they grow and they ask very curious questions to parents. Well, why it is happening? What is it? What is this? So, explaining things is one of the intelligent tasks. So, observations, you are observing things in the world. Can you explain that? Well, I can talk about that later on. We'll talk. The explanation. The doctors are here. If I go with them this set of symptoms, what doctor does? Try to find explaining, telling you that these are the possible diseases might have caused those symptoms. This is an intelligent task. Okay? You agree with that? What else? Once we observe the world for some time, then we gain some experience. Based on that experience, we like to see what will happen tomorrow. Predicting future. Okay? Smart people can predict the behavior of the stock market. Smart people can predict, like by observing farmers, I'm from farming family, by looking at certain parameters, observations, they used to predict that next day there will be rain. Okay? There was no like data collection, like today we have the data, we can use data to make those kind of reasoning, but it used to happen throughout the human history. So predicting future. Now, third activity our brain does, that certain things we learn, okay, and we acquire some knowledge. We want to use that knowledge for meaningful tasks. So that process called like what we can deduce, what we know, and what further we can deduce from the what we know. Okay? What more we can know from what we know. So these are the three essential reasoning processes human mind does. You know, that's my view about logicist view of intelligence. Now, in philosophical terms, what do you call? Apologies for the symbols here, but it was those who know the basic logic. The first principle is that from philosophy comes like abductive reasoning. When you start the explanation, all diagnosis is abductive reasoning. You observe something, try to find the right hypothesis to explain it. Okay? Scientific discoveries is the abductive reasoning. Okay? And so if you know like P implies Q and you have observed Q, then you can abduce P, usually if there is no contrary evidence on that P. Okay? So this is not, forget about technical thing. Predicting the future. There's a lot of buzz about machine learning today. Data science, machine learning, everybody talks. Machine learning is not different from AI. This is a part of the AI, one of the components of AI. And inductive reasoning, we call it induction principle. The principle is that if you go somewhere and observe, there is one swan we have seen, the swan is white. Then you can generalize, all swans are white. Generalization. is the inductive process. Election results people try to generalize. Okay? That is the inductive reasoning. Machine learning, you train your network and try to predict something. This is inductive reasoning. And the third reasoning we call the truth is truth. What is the difference between them? You will see that first two kind of reasoning, you cannot guarantee the correctness. You cannot guarantee, like machine learning, you cannot guarantee the correctness. Never ever doctor can say mathematically proven his diagnosis is correct. It is most likely correct. But mathematically they can never prove it. In the same way, no scientific theory will ever remain correct. If a theory is scientific theory, by nature it must be potentially refutable. If there is an observation that cannot be explained by that theory, then we have to change the theory, we have to revise the theory. Look at the Newtonian mechanics. Everybody knows Newton, right? When he saw the apple falling from the tree, he came up with the great principles. But when Einstein's time, nearly 200 years later or 150 years later, they say, how about if this piece of mass, if you throw the speed of light, those principles cannot explain it. So you have to change it. And honestly, I was a science student throughout my life, but I could not understand the meaning of scientific theory until I read the great philosopher, one of the philosophers of science, Karl Popper, which I gave you the example like observations, and we'll come back. And I can answer that question. In order to reason with observations, you need to have hypothesis. Okay? So hypothesis and observations are like chicken and egg problem. Okay? But that is the kind of essential ingredients of the growth of scientific knowledge. Okay? So I'm going now quickly. Sorry, I love to talk about these things, and I know that you don't have the background in the, some of you might have background in the computer science, so technicality, but let us go to the AI system. So the explaining the past, I'm trying to bring together like what the buzzwords people talking about in the business, descriptive analytics, predictive analytics, and prescriptive analytics. They all come close to these principles, okay, what I mentioned here, okay. And what ideally we are looking for AI systems, that system has all these capabilities. All three reasoning processes should reflect in the intelligent systems. Any machine you build, we have to see that one. And then we can make the rational decision. Machine should not be biased. That's the one argument that AI could play the fair game. Okay? But again, it's a human being who are programming it. Okay? It has to be interactive. Like operating system, most operating system could be treated like agents. You type your iPhone or any phone or PCs. What is the operating system? It is a kind of intelligent agent in the way. You type something, it responds you. Okay? And by the way, John McCarthy, the founding father of the AI, the first operating system was designed by him, encoded in 50s and 60s when he talked about thinking machines. So people in the AI were also the core computing science people. Okay? So please, I think if you have questions you might ask, note down the questions. Later on we can talk about that. So these are the basic introduction I'm trying to give you. And if you remember this one, that will be great. Okay? Now, a little bit about history. So when we talk about intelligence, a lot of activities are intelligence activities. These principles are the fundamentals. Okay, I explained you three principles. Like natural language understanding is intelligent activity. Recognizing objects, expert systems. Even early 80s, we have a system called Menon, which used to give advice about what is the right drug for those kind of diagnosis, And dendral system, giving the chemistry new invention of, chemistry. Chemists use that dendral for identifying new structures, speech recognition, autonomous systems like robots who's cleaning your floor, okay? Optimization and search, computer vision. So all these fields in 60s, people think that there are too many. Then the different communities emerge. Professor Kuldeep Paliwal, some of you know him. He's an expert in speech recognition. He took this one area, his area. In the same way, then in 60s, there was a diversification. These people developed their own communities that each of these tasks are so difficult. 40 years later, in early 2000, people realized truly intelligent agent needs all of these capabilities. So it's the time to remarry again. So that's what when I founded the institute at Griffith, I called it integrated systems, intelligent and integrated system. And you need all these capabilities. So, and that's what's happening now. We are seeing the progress, and these are the people, some of the leading people. So, anybody recognize who is on the top corner? Who was the mathematician who changed the course of the Second World War? By enigma. Who was that? Alan Turing? Turing. And Turing is also founding father of computers, modern computing science, from mathematician. And he also the one who proposed the first AI test. Unfortunately, died very young age in 52. So that was in top corner. So it was early stage, 60s. I'm talking about how people were considering what is important, whether logical thinking or reasoning is important, or speech or natural language or vision. They all are interrelated problems. Okay. Now, there was a time when people didn't believe it. They say that AI is a fiction. In the 80s, and 90s, you see 80s and 90s, there was a lot of confusion, but funding agencies also very mindful of that, whether they fund or not. But somehow AI people keep surviving, because whatever the progress they made in AI field that was useful in other fields. Anybody who knows computer science know this object-oriented programming, structured programming, all came from the AI originally. Okay? Then database people ran out of the ideas. They used this machine learning application called knowledge discovery, data mining. This is machine learning. So the people survived. Now, important point here to mention, can you recognize this person here in the 2000s here? I think the slide was made before. His name is a professor at Toronto now. Hinton, Geoffrey Hinton. Geoffrey Hinton is a person who basically gave a lot of scientific work on the so-called deep learning, neural network, popular buzzwords nowadays. And do you know what? This year's Physics Nobel Prize, who won? Geoffrey Hinton got the Nobel Prize for his work on the neural aspects, because his work was based on that intelligence works from the brain is a kind of a society of neurons which are interconnected, and intelligence emerges. The problem is the logic people cannot explain, because they like to see the transparency and clarity and explanation. So the two camps were always there in AI, but now they are merging together. So, and Geoffrey's work was the most, I think, cleanest work in this connectionist kind of work, and it was recognized this year. Okay, so OpenAI, the today's story, you go and type any chat GPT, you will find some answers. Not necessarily all answers are correct. It is you have to own, you have to verify and try to do it. Okay. So that was my introduction to the AI, very brief, and please feel free when think about the questions. And when I make a comment about the observation hypothesis, this was not my idea, it was the Karl Popper. When he went to his classroom, he asked the students to write down whatever they observed. And next question he asked about the reasoning. Nobody could reason. So that's the idea came, hypothetical reasoning. If you look at our ancestors, human ingenuity or history, what would be the first hypothesis on this earth? Humans might have thought. If they go around, they see two kinds of things. One thing is flowing around like water, liquid. Another is a solid. The first hypothesis would have been this world is made up of two kinds of things. Imagine, Then somebody observed the smoke. Oh no, this hypothesis cannot explain. Then, oh no, world is made up of three kinds of things. Solid, liquid, and gas. And that hypothesis might have lasted so many years. So this is the process how scientific knowledge grew. Okay? So, I will be happy to answer more questions, but this is my view about AI. So, understanding intelligence, developing theory of intelligence, and then building machines which can exhibit those intelligent behaviors based on those understanding. So, a lot of things we still don't understand. Common sense. In the absence of complete knowledge, humans use common sense. The default reasoning. Okay, default reasoning by nature unsound, but machines can't perform it. So my PhD was on the hypothetical reasoning when I did in mid-80s in University of Alberta. Okay, so some of the good stories here. How many minutes are here?
Got a good 15 minutes.
15 minutes? Okay, good. So these are success stories. Like Phoenix, there's a driverless cabs there. I don't know whether cab drivers are around, but this is the reality. It is happening. Okay, so it is about 315 square miles area in Metro Phoenix. This company called Waymo One that operates the taxis without human beings. A few examples I'm giving. There is one popular term being used nowadays, large language models. Okay, large language models basically integrates the machine learning activity, natural language processing, computer vision, etc. Is again integration. When I talked about how the development in all sub areas now coming together and trying to merge together. So large language models is one of the efforts, and that's what this ChatGPT or OpenAI is based upon. And look at the right hand side. These things are computer generated art, creativity. These are you can see tutoring, learning opportunities for students. Everything is available nowadays. As a professor, I see that why not many students attending classes? Because now they can learn anything, anytime, anywhere. Even the difficult courses, there's so much resources available online, and they can learn. And now the AI agents, they can personalize them, what they want to learn. So AI is one of the great benefits for education. It's still in the premature stage, but it is coming up. Okay, you have seen, I think Chinese have come with the very smart and more competitive system now. Australia has banned it. So, you see DeepSeek. Okay. Next important thing which concerns all of us. We have seen the progress, and now it is the governments and society in general, we have to see how responsibly these advancements in technologies can be used. So as an AI scientist, I have been involved in many of them, and around 10-15 years ago, I think, I remember when I was in III conference, and the physicist had one dilemma in 50s after invention of the atomic bombs. They were thinking whether they did something wrong. It is so devastating, and how many people killed in 45. Okay? And same thing now, AI scientists are confronting. What could we do? The intelligent machines you are building and its operators. The people who will make decisions to use them might misuse them, and it raises the ethical issues. So, the three important issues I think we are confronting about responsible use of AI systems, the regulations, and the ethics. I don't know how many people care about ethics, but these are the important things. And I think I admire Europeans. Europeans are the first to enact the AI Act in Europe. People cannot just use it, but they have to. And those who collaborate with the European industry, some other industry should also comply with that. So that's a good thing. So AI scientists in general nowadays hoping that what came with the nuclear, like all these bombs and those things, some sort of regulation like non-proliferation treaties or that kind of thing. So we're hoping that the governments around the world will eventually come up with some sort of regulations and understanding that can prohibit people misusing the advances in AI. Every technology has pros and cons, and the human being who is actually responsible, And recently I have the first student, I think I had, who did a PhD on ethics of autonomous vehicles, and I don't know much about ethics, so I have to work with the people in moral philosophy. So I brought them on the co-supervision team, my friends from the you might know, humanities faculty, some lawyers and some people who are doing the philosophy. And it was a very interesting learning experience, how philosophers view about these things, And so computer science, AI in general, now it can also bring different disciplines together. Like it is not, okay. It can bring people together. So it is not the one field, it is like you look at the social sciences, even, of course in science you can see the applications, but environment, social sciences, everybody can come and work. Without those intelligent machines, we can't progress now. They become part of the society, part of humanity now. Okay, so thanks for reminding me time. I will not go details, but I will just skip through AlphaFold 2, the two things happened this year, and the great things, like AI can be used to solve some of open problems, and especially in the life sciences problems. What is life? A protein is a fundamental block of life. Do you agree with me? People from medical background can testify it. What is a protein? It is a sequence of amino acids. What is a sequence? It's like a garland. Amino acids are connected with, the garland. But why it is alive? There is one particular shape of this garland in 3 dimensions that determines the function of that protein. Okay? Whether you have bacteria, virus, whatever, whether it is active means a particular structure. That determines it. So what medicines do? Once you know the structure, you dock some carbohydrates to destabilize the structure, that kill. Means the shape is changed, means it's no longer functional. That's the big problem. We have nearly 200 million sequences about life, plants, everything. Do you know how many sequences we know the structure? Less than 200,000. AlphaFold 2 is a Google's program. AlphaFold 1 was there. They trained because they're huge resources, about 170,000 known structures. And then they made a lot of good contribution. They try to predict So idea of using AI in life sciences is that can we use the AI to predict those stable structures, like rapidly evolving diseases, Sometimes for humans, it takes years. One drug takes a 10 years, 12 years cycle to build. It's more than few $1 billion worth. It costs a lot of money. Can AI help it? Like dengue. There are 5,000 different strains of malaria. We don't know all of the structures. Dengue fever, there is no cure at the moment. We just have to manage it. So this AI is the future. AI can help us. So what I brought it here is the one great application. And my group has been working in this area for last 15 years or so. We missed the Nobel Prize, but we knew that this is a good problem to work on. So several 10 plus PhD students came in that. And I think I admire Google, at least they spent the huge resources to build the big system and get it. But then another person, the David Baker from the University of Washington, I think, and he had the program called Rosetta, who was doing great work for last 20, 30 years. And so he was recognized for half of the Nobel Prize and other half was given to the Google's AlphaFold 2 team. So this is a testimony that AI is now contributing in advancing scientific knowledge. Okay? And I think this is a strong evidence. Now question comes, I think Salim Saab will talk about this more. I will just go quickly from here, and because there's no time much. Let me see. So these are my technical results. I will just go in the end now. Okay, these are the work we did about the protein folding, etc. Fold 2. I have collaboration with eHealth Center as well, so won't talk about that. So these are all my stories. The ethical issue comes about autonomous vehicles, Look at this example here. If there's a pedestrian illegally crossing this one and the motorbike coming behind this vehicle, what action it should take? What is your opinion? Slam the brake. Okay, but then motorbike, he will die. He will hit it. So my student, I mentioned about PhD, he did 83% of the responses from his surveys. They say slam the brake. So they say because human beings, the humans will take that decision. Okay, and guys coming from back, they both are illegal. One guy is going too close in the behind, one guy is illegally crossing the road. So these ethical issues, how to encode them, that's a challenge for AI. And how to regulate them. Okay? That's the possibility, yeah. So the killer robot, my friend recently wrote a book, I think Toby Walls, I think, and it's a very interesting story here. I will not go. Okay, so there are a couple of more minutes, so we talk about future. Okay, I could spend time for each of my stories for all time. There's a lot of the technical thing, but I hope so far it's not too stressful. Okay, good. Thank you. So what is my prediction and for future generations, basically? If you go and look at the challenges we have, understanding evolution is still a challenge. From theological point of view, we strongly trust on the religious theories. People don't want to change it. But as a scientist, often have to keep the open mind. Okay? And my view is that all the scripts, like in the theological scripts from different religions, they are the great, kind of a guidelines to the human beings. Okay? I'm not saying picking them in particular, but also, if a logicist point of view, there is a lot of paradox, you can say paraconsistency. The good people can take the good part, bad people can take the bad part. So there is a paraconsistency exists on those, It is not their fault, it is the people how we interpret that. So if you look at the Islamic history, because a lot of people are Muslims, here when they growing the scientific knowledge, this solar systems theory, if you look there, when in the observations in the current Syria, Baghdad, Iran, they were not explaining the flat theory, then they have to change the theory. The original book was still in the, I think, Italian some library, which we give to Nicholas or whom, the current solar structure. So idea was that people used to question that. The questioning is a part of, some people think that it is our religion tells that we cannot blindly accept things without reasoning. So there is contradiction. What I mean is that, and nobody is wrong, the people, everybody is right in their own way, and we should not judge each other. That's the fundamental thing. But being a scientist, we have to keep open mind, and that is also a good approach. So these questions are very difficult questions, origin of life, So the future generations will be keep talking about that. And what, as an AI scientist, I feel very happy that the few of these great results were recognized at Nobel Prize level, because people thought that they made worthwhile contributions to advance the knowledge. And what is science? Science is advancing knowledge. We are, whether knowingly, unknowingly, whether accepting or not science, every day we see the advancement of the knowledge and we are using it. So only time is that we have to interpret it in a nice way, so everybody can coexist and there is no contradiction. It's all for good for human being, good for society. There is a fundamental, everybody can see what is a good and what is a bad in society. So if AI is for good, everybody should endorse it. And that's my view here. You can see this like protein folding problem. So what will happen? Drugs will be produced very quickly. Oh, sorry, this is like this, all I mentioned about already. And I saw that there was one company produced some drug in 21 days. I don't know how reliable this is, but that will be interesting to see. And these are the applications. Like humanity is suffering from food, the food security, the agriculture, water quality, pollution. So where the AI can make the big difference. Disaster management, people are working in terms of future. You can see what happens when during COVID's time. In many countries, people were not even handling their loved ones, So here is the rescue for the robot. Surgeries will be done and robots can play. This is the last slide here. And so there are a lot of challenges. AI made a lot of progress, but still there are a lot of challenges, like how to make it trustworthy. In order to make it trustworthy, we have to make the opening the black boxes of the deep learning stuff, we make it explainable and transparent. And so my view is that symbolic and connectionist approaches are coming together. They have to elegantly merge, so they will produce more acceptable systems in future. Thank you. And of course, I think this is a responsibility for societies, like how we want to use it. Can AI be fair? Can be ethical? These are the questions we will keep debating over the next this century, 21st century, I would say. Okay, so I close here and thank you very much. Sorry, I might have taken more time. Okay, questions will be later, isn't it?
Yeah, questions we
Yeah,
have.
okay.
Okay.
Can I have some water? Okay, okay. Oh, thank you. Okay. Oh, yeah. Thank you.
Hello everyone, my name is Salim. I'm a lecturer AusIndia. So I'm here with this tonight. So his name is Salim, and he's a medical director for digital transformations at GOPIO. So a brief introduction about Dr. Salim is a innovative leader in digital transformations at the GOPIO hospital and health services, pioneering projects like virtual inpatient, AI, medical imaging, and remote patient monitoring and management systems. So previously led the largest inpatient unit at Gold Coast Hospital. They're spearheading key initiatives such as general medicine, short stay unit, and service reconfiguration. So a specialist in general and acute internal medicine, certified by American International Medicine and the Royal Australasian College of Physicians. With a strong passion for technology-driven, patient-centered healthcare setting. So basically, Dr. Sattar did touch some of the points on medicines that Dr. Salim will go deep dive a little bit. Proud to introduce and invite Dr. Salim.
Thank you everyone for joining in today, and Dr. Abdul Sattar did a very good job in doing the academic side of things, and it was very interesting to understand because my job is more on the practical side, so I've never thought in the way that you thought, so that was very interesting to hear. So I work in the Gold Coast University Hospital. We have a whole department that focuses on innovation and digital transformation within the healthcare sector. So I medically lead the department along with a whole team of technical experts as well as integration specialists and whatever we need for that. We are one of the pioneering hospitals across Queensland and almost across the country as well in delivering technology within the healthcare sector. And the idea is to improve patient care, access to care, reduce errors and improve the quality of care. So I'll be talking a little bit more about what I do in terms of the technology within the health sector, but also what are the potential applications going forward. If possible, if technology assists us today, we'll try and do a live demo of AI that we are using currently within the healthcare sector as well, hopefully if everything works good. So let's get this to work. Okay. So I won't go into the in-depth what Dr. Abdul Sattar did, but I'll sort of touch superficially on what is AI. So for me, more as not an academic but a practical application person, I'm looking at AI as a technology. I'm using computer as a technology here that can perform tasks that usually would require intelligence. So for example, if I want to calculate 5 plus 3, a calculator can do that, has been doing it for many, many years. But it's about doing significantly higher level of calculations and deductions that require intelligence, which requires learning. So what was A plus B was C 3 years ago, but now 3 years down the line, A plus B is actually D. And how does that machine learn that and continues to adapt to that new learning? Does it make reasoning behind it, as well as part of its deduction or answering of the, as part of its answers? And can it make decisions? It's not just giving you an indication, but actually deciding for you. So this is the sort of the big basket of AI. It has got a lot of components in it. Previous speakers spoke about a lot of these. So what we hear about these days, generative AI, natural language processing, these are different techniques that are within the scope of AI. Every single element can be called AI, but then there is, technologies that integrate all of this to develop a product at the end. I'll touch on a few of these, but these are the sort of, main sort of subsections within the technology space. So generative AI is something that generates more information that wasn't there previously available. So it can develop text, videos, images, whatever you want, and even writing programming codes and stuff. So some examples of this, ChatGPT is the most common example, because you can understand Google's sort of Bard. Machine learning is when the technology automatically starts learning. An example of this would be, I told the computer A plus B is C, and it keeps saying that A plus B is C. But the third time I say, hey, listen, A plus B is actually D. It learns from that, and next time I ask it, it says A plus B is D. That's what the learning is all about. And every time I give it a positive or a negative sort of reaction, it learns in the background. So that is an open source sort of platform which continues to learn and adapt. So that's called machine learning, basically, in simple sense. It's more detailed than that, but I'm just giving you an example of what that means. Okay, so in that way, it can start making predictions. So when it involves more complex questions, it uses that. Okay, Salim said A plus B is D now. So in every next answer, it will use D as an answer. But even in the complex ones, it will continue to use that. Natural language processing. So if I tell the computer, listen, I'm feeling very sad today, and that it just knows that information as a text. But today, if I feed that in and there is an application, it knows that I'm sad, and it will usually ask me, why are you sad? Right? That's what it's processing. It's processing the information that has been given to it, and is responding back. So that is called natural language processing. It's about understanding, but also generation. So there's two components in it. But it's about, if I tell, if I go and travel to Japan, I can't speak Japanese, and I talk to people there, I can speak in English, and it translates similar sort of natural language processing. So it's about understanding the text or information, whatever we provide to them, contextualizes the application. So whether am I translating, am I responding back to this person? So those sort of things, that's natural language processing. And the reason I'm doing this, because some of the applications that I might talk about will have some of these technologies integrated. Computer vision. So if I take a picture today, as everybody knows, like it will take a picture of anything, like scenery or a computer, or we sitting in the library. But what's important with computer vision, it sees like, okay, if I take a picture, it can tell me, okay, there was 50 people here. One person in the front row was wearing a black hat. There was 3 people with glasses. There were 7 females and 10 males. That's computer vision. It's telling you that in-depth information after looking at a picture to say, this is what the information is, this is what I can derive from that. And it's getting more and more smarter, right? So that's, like currently I use a car which has got like the adaptive cruise control. So it knows that there is a car in the front or an object in the front. I need to maintain that much distance. So that's also some form of computer vision. It's recognizing the object coming through it through radar or sonography or whatever, and then tells the machine to brake or speed down. So these are all sort of different techniques within AI. But any product that we use has a combination of these. Some of these are like single, but most of them have a combination of these. So healthcare looks more on the left-hand side kind of thing. If you still go to the doctor's room, you'll see you'll wait for half an hour, 45 minutes before you see a doctor. But if you go to see, some of the other professionals, they work very fast. So it's still in that phase where it looks like when we are within healthcare working, that we are still using the paper maps and looking for the roads and stuff. That's what healthcare looks like and feels like. Whereas we have the technology now, which should look like the one on the left-hand side, where we should be able to know who is the person coming in next, and more information about them, and should be able to guide them before they even walk into the room, that this is what we'll be talking about today. And after they leave, they should leave with that information to take back with them. But none of that happens. As you know, 80% of the people who go and see a doctor, they don't know what information they got. That's the research. They come back saying, I really don't know what the doctor spoke about. It's very common. So how can we change that? And technology can help us, because obviously, I'm talking about business side of things now. Doctors have to see more patients to make more money. Otherwise you won't get enough money. So you're rushing through the patients. It is human nature. Secondly, it's the variation in practice as well. So a doctor that performs at 8 a.m. in the morning is not going to perform at the same level at 4 p.m. in the afternoon on a Friday evening. So how do we reduce that variation using technology? So as I said, it still feels the more that we're on the left-hand side, where we can move towards what it should look like. So now that we know what AI is, and we know the academic and practical stuff, and what it should look like, what are the current use cases within healthcare? So every time we go to a doctor, a doctor is typing notes or making notes somewhere, writing scripts and whatnot. They're not looking at you. Don't look into your eye. That's where you get most of the information. So I grew up in India. We wrote like 2 lines in our notes, which was not right. Now thinking about in the past, but at least I looked at the patient. Now we don't look at the patient. We look at the computer screen, and then we're typing or writing. The connection between a doctor and patient is completely lost. And that is because we need to document a lot of information to get the money from Medicare for medical legal purposes, for whatnot. That is changing very rapidly because now we can use this technology to do all that stuff so I can focus more on the patient. And this is one of the technologies hopefully I can demonstrate today that we are using within Gold Coast. We are the first hospital in Queensland that has been able, public hospital that has been able to roll this out. So scribes, we call them, which can write the notes for us, which can do all the grammar, punctuation, the niceties and everything. So that way I don't have to worry about my grammar and punctuation. Clinical decision support systems. What does that mean? So a patient that has a pneumonia, who is 60-year-old and weighs 60 kilos and is a female with no allergies, is very different to a patient who is 45 years old, weighs 130 kilos and has got allergies to penicillin and other drugs. So for both of them, they come with the same infection. I need to treat them differently. But to do that, I need to use my brain, which I should. But at the end of the day, the technology is evolving, the drugs are evolving so much that I can't keep up with the dosages and the names and how do I dose them? If the kidney function is this much, I need to reduce the dose by this much. This technology can tell us that now. It can guide us to say, okay, for John Smith, you can choose ceftriaxone at 1 gram once a day. Okay, but for Joe Blow, you probably need to consider it at 2 grams twice a day because the infection is different or their sensitivities are different. So providing that support makes us do the right thing for the patient because you don't want to be doing this, experimenting to find out the next day, oh, I gave a reduced dose or I gave too much and now they have a medication error. Radiology. How many people have had an X-ray and you call the GP clinic, can I get their X-ray report? If the report is not back and you call them back and the report is not back. It happens all the time. How can we use and harness computer vision to deliver those results instantaneously, almost instantaneously? This can happen now. And hopefully we'll, I'll show some of these examples, in my slides. Okay.
So just one very quick question.
Yes.
When you take a decision based on the clinical decision
Yeah.
system,
Yeah.
how confident you are with the response which you got from the AI?
Yeah. So
Is it right?
yeah. So okay. So I'll answer that. So while we are fixing this thing.
You can answer that.
No, it's okay. I'll answer that because it's an interesting one. So it depends on the system that we are using. So okay. So I didn't discuss that. So not every AI model is developed for the population or for the context. Okay. So for example, if an AI model was based on people in America and their drugs and systems there, we wouldn't accept that model within Australian healthcare system. Okay. So that's one. Secondly, usually all of these models have to have an explainability charter or some nature to say, why have you suggested this to me? And I'll come to that as well as the benefits and pitfalls and considerations. Because if you can't explain to me why you're giving me, I won't trust you. So one of the things that we focus on very heavily is explainability of the results. Okay. Okay.
Sorry.
That's why we can go back. You'll go back? Yeah. Okay. So just leave there. So predictive analytics is about how quickly is this patient going to get better, but also, Gold Coast University Hospital has got 1,100 beds, but we still have patients languishing in ED. And the reason for that is because we don't know how to manage our systems. So when we have floods every 10 years or 20 years. We don't have floods every monsoon except in Mumbai, we have it every now and then. The idea behind that is we can predict things, and because of that prediction, we can make adjustments, but we don't do it within healthcare. But now the technology is available. So looking at the data for the past 10 years, we can say, okay, in April, generally, we have on a Sunday, these many people who will rock up to the emergency department. So can we plan for that now rather than reacting to it? So that way, going into that long weekend of Easter, we know how much staff to keep, what other resources we need. Now that technology is available to us, or the data is available to us to make those predictive sort of information. Endoscopies, a lot of elderly people would have gone for sort of endoscopies, or even young patients who need endoscopies done for various reasons. A lot of the times when we do endoscopies, we are basically, it's a camera on a tube looking at your intestine or your stomach. We're going through looking for something abnormal. But imagine like you're looking into an ocean for a small fish, because that could also be abnormal. Sometimes we miss as doctors. We're humans at the end of the day, So can this computer vision see that all the time? Because that doesn't get fatigued, whether it's 8 o'clock in the morning or 4 o'clock in the evening, and pick up and indicate, hey, listen, by the way, I don't think you looked here. Look here, there is something that might be critical. And pointing and saving lives, in the long run. Virtual health assistants, these are for general population, but also for doctors as well. But mostly talking from a general population perspective, the examples of that would be somebody who's feeling suicidal, quite depressed. What do they do? 12 o'clock at night. There's no GPO, when there is no psychologist going to take the phone call. What do we do now? Can we use technology that understands that person's sentiment, has got the algorithm, which is the technology in the back, made by clinicians and psychologists, guide them and prevent them from committing something that could be very harmful to them? Because this is a very isolated nuclear society. We don't live with big families as we did in India. So how do we prevent that from happening? That's one of the examples. And many more, including drug discovery. Dr. Sattar also mentioned about that. That's obviously happening at a rapid pace, but we haven't used the technology yet to develop new drugs yet.
So does that also be with the capsule endoscopy?
Yes, so it's all with capsule. It's still in a early phase, but with the actual endoscopy, it's already available, and we are using it at some of the hospitals. We'll try and do this live demonstration if we can. So if we close this down and go to the page. Okay, let's see if it's open, this one. Okay. Let me just take this off. So give me just 1 second while I pull this up, because Alright, consult, okay. Alright, when I tell you, just to start listening and click on this. Just click on that when I tell you.
Start listening?
Yes, just to click on initial consult. Yeah. Alright, so this technology obviously we are using to generate notes for our patients within the hospital. So our doctors no more sit in front of the desk and write notes and stuff. They're using this technology to be able to deliver the notes so they can talk to the patient. And second thing is they go home on time. A lot of the doctors are sitting after hours writing notes and stuff, and especially for the young junior doctors, they have families, they have young kids. We want them to go home and enjoy with them, their families. So, okay, so this is completely unprepared. So, anybody here can come. I will just talk to them for 2 minutes to show you how this technology actually works. And so any volunteers who want to come forward, I'll just talk to them quickly about their health condition, and then we'll see how this works. All right, Dr. Dean.
I suffer from ulcerative colitis.
All right. Why don't you come here? We'll talk about your ulcerative colitis quickly and see if it picks up all the information. So, Auntie Dean. All right, take a seat. So, Arif bhai, let's start. Let's all right, click on that. So I'll take your consent. Are you happy for me to use AI today in my outpatient? Okay, I put my name for now there. Okay, so just cancel that. Just begin, and just allow.
Yes.
Yeah. All right. So, Auntie Dean, how are you feeling today?
I'm feeling very well, thank you.
Tell me, how old are you?
I'll be 83 in August.
Okay. Tell me what brings you to my clinic today.
I've suffered from ulcerative colitis for over 30 years.
Okay, ulcerative colitis, 30 years.
Yes,
Okay.
and I have to have colonoscopies and endoscopies every 2 years.
Okay.
I did have my appendix out and it stopped the bleeding
Okay.
with Dr. Abdul Smith.
Are you allergic to any medications?
Yes,
What-
sulfur drugs.
What happens with them?
I get rashes.
Okay.
I had dipentum tablets.
Okay.
But they've taken that off the market.
Okay.
So I've got a new drug out now.
What do you take for your ulcerative colitis?
Not sure the name of it.
Okay. Is it an injectable drug or a tablet?
It's a very big Crimson tablet.
Okay, you take it every day.
Yes,
Okay.
once a day.
And how's your bowels now?
My bowels are very perfect.
Okay, perfect. Okay. Now your examination looks normal at the moment, so, and your blood tests look also normal. So I'll schedule a colonoscopy in 6 months' time, and we'll send you some information a month before to prepare for your colonoscopy. But other than that, you're up to date with your vaccines and everything.
Yes.
Do you need any scripts today?
No, not really. I've got everything up to date. The only trouble is, a lot of doctors tell you shouldn't have colonoscopies after a certain age.
Yeah, but you are different because you have ulcerative colitis. So we might do that for you just to keep an eye on the inflammation. All right, I'll see you in 6 months' time.
Okay, thank you.
Let's stop that. Thank you. See if it's done the job. So as you can see, I was focusing more on Antidine. And here you see that it has come up with all the information. So I've just scrolled through that. So you can see it's picked up everything. If you scroll it down, Arif, there, so ulcerative colitis, no medications. So you can see it's not 100%, right? You still have to look at it. So as you can see, and it could be because of the mic here with not 100%, but it says no medication allergies reported, although she said it's sulfur allergies, right? So I have to still listen actively, which I do. But what it did was it actually took away the need for me to keep typing all the time, right? But so that is basically, your generative AI, listening at information, a large language model in the back, which is medical in nature. Now, if I go to write document, or if you do that for me. So this is for me, right? But if I need to send it back to the GP, I'm a specialist, right? If I do write document, click on that, and I say I want to write a medical certificate or a letter to the referring clinician, and I click on write the two documents. So it does that for me as well in a prose form. This was a dot point form, but here you can see it comes in a nice prose form. So I can send that directly to a letter back to the general practitioner, GP. This is how it's transforming. I mean, this is one example of many, within the healthcare sector. So I just wanted to give you a flavor and taste of what this really looks like.
You're right, and it is true in legal contracts as well.
Exactly.
But again, the individual human beings have to take the ownership.
Absolutely.
So they have to check. But it's a great assistive tool. That's why we always call like AI as assistive tool.
Can I ask again one?
Yes.
This kind of technology, because you are in the workforce.
Yeah.
How frequent or how really available this kind of stuff? Is it really?
So it's like that Nokia mobile, when it first came, it was 50,000 rupees, but then it was selling for 500 rupees, at every corner. So I think as the technology gets developed, I heard DeepSeek has been developed for fraction of the price of what they did for, OpenAI. So obviously as technology gets developed, we know, and there'll be more players in the market. I think it'll become easier. So in terms of availability, anybody can buy this. It's called Lyrebird. There is 5 different other competitors now. It's $300 a month. It's not much, but if I had to, have an admin person just doing the typing, I have to pay them, at least 8 to 10 grand a month, for doing some of these things. So absolutely game changer for us, especially, we see 25 patients in a day, then I have to review all the notes in the evening, sit and worry about. And the thing is, I review the notes after I've seen 25. So I don't remember what was the first patient, So it ambiently captures all the information, puts it into a format that we need it. If you let us, and then brings in different formats that I showed you. And this happens instantaneously. It's not like it's taking, hours or minutes. It's happening. So while I'm wrapping up and shaking my hand with the patient, the notes are ready. And I can send this and put into my electronic records and stuff. So next slide. So what are the next steps? So obviously this was a live example of, what happens. And this is more the low-key stuff. Let's look at some high technical stuff. So here, I don't have the technology with me because it's very hectic to bring it here. But anyways, here what you're looking at is X-rays on this side. So let's focus on this side of the screen first. So this is an X-ray. To a lot of junior doctors that would look normal. They wouldn't be able to pick up some abnormalities. So this is the left lung, which is normal, but the right looks almost the same. But if you don't have those circles there, you wouldn't know there is abnormalities. But now with computer vision, the technology can pick up and highlight those areas in the X-ray. So a junior doctor who is first year into medicine after finishing medical school exactly knows at that point in time when they are an intern that, hey, there is something wrong, I need to talk to my senior. Whereas, if a junior doctor is seeing you and they might say, okay, there is nothing wrong here, right? And a potential significant abnormality might get missed and you might not be treated for it. Or worse enough, you would have gone home, they pick it up after 6 months and then tell you, but if it's underlying cancer, it would have progressed. So huge lost opportunity. So this now technology is available for chest X-rays. So imagine the feeling when you go for an X-ray and by the time you come back to your room, the report is available and they can tell you right away. But there is still a loophole here, that how does the doctor know there is an abnormality? And I'll come to that. So that's the X-ray, chest X-ray technology. This is the CT scan of the brain. So again, this is quite obviously abnormal. But again, to highlight the abnormality in the chest X-ray and the CT scan of the chest, this technology is now available. So whether you are a radiologist or not, whether you are trained in doing and looking at all of these things or not, you now have the technology to assist you. So you can do more clinical stuff. You want to go back to the patient and tell them, hey, listen, something is wrong, let's fix it, rather than trying to work out what is wrong. What we want to be focusing more time on, hey, let's treat this and how can we treat it best. Next slide. So now, once you have the information available, so at Gold Coast, what we are trying to now work is, okay, so information is available through AI that something is wrong. But now that technology, we are using natural language processing. So this is how the report will come up, that there is something abnormal. And we have to give in the background a logic that there are certain key elements that are called critical. And if it picks up a critical result, it will automatically ping the doctor on their phone that there is something very critical that you need to look at it right now. So if I have 5 patients that I'm seeing on ward rounds and I order an X-ray on bed 1, but by the time I'm seeing bed 5 and the X-ray is done and reported, I will not go and see that X-ray right away. I'm doing other things. But if there's something critical, it will ping on my phone to say, hey, listen, the chest X-ray you ordered says something wrong. So I can leave that and go back to that patient and address that problem. So it's about integrating now computer vision, natural language processing and technology to ping me back. And it finds who is the doctor and what's their number and pings you back. So it's about, there's a whole lot of sort of technology involved. And for the radiologist, so the workflow currently is, so when you go to, let's say, Woolworths, if you're the first person in the queue, you get served first. Same happens with X-ray. If you went the first, your X-ray gets reported first. The second person's X-ray gets reported second. The third person's X-ray gets reported third. But what if the third one was more critical and the first one was normal? And the third person had to wait for, maybe 20 minutes or an hour or sometimes days. So now the technology can rearrange the list from the critical to the non-critical ones. So that way the critical ones are reviewed first and also can be given to the more senior people.
Who determines the criticality?
So it's the AI that determines the abnormality first. Then the abnormality has been given a critical nature. So there is 4-star ratings, like starts with 1 star, which is like, abnormal but not critical, then little bit serious, then serious, and then critical. So like there shouldn't be any air around the lung. Inside the lung is fine. If there is air around the lung, it's critical. If there's any blood in the brain, that's critical. So those sort of things, quickly highlighted, send it to the doctor so they can action. Anyway, so that's, hopefully that helps. So this is artificial intelligence in the endoscopy. This is what the normal sort of your inside of your intestine should look like. But can you see it doesn't look too abnormal here, but it is actually abnormal. So this is what AI can pick up. So somebody who is novice, has not done too many endoscopies, or if they're tired at the end of the day, after 7 days of working, they might miss it. But now you can pick up these things with computer vision and they can indicate to you right away. So as you're doing the colonoscopy, it starts pointing it out to you to say, hey, these 6 things are looking abnormal. Please focus on that. So we can go do the biopsy there and not miss anything critical. All right. So we spoke about, obviously the technology. So let's talk about the benefits, like from a general perspective, not specific technology itself. So efficiency is the biggest benefit, right? So we can do things much faster. We can attend to patients much faster, get them information back to them, treat them much faster. It's about efficiency. We want everything to be faster. We don't want patients to be sitting in emergency for hours. And that's what happens. We're waiting for the result of the CT scan, and then we're waiting for the result of the X-ray, and we don't know what antibiotic to give. all these decisions are getting done much faster now with the use of AI. So efficiency, we're doing it more accurately. I gave you an example of somebody who is 80 years old, weighs 40 kilos versus 60-year-old with 50 kilos and the allergies. Giving more accurate diagnosis, giving more accurate medications to patients. Imagine chemotherapy. We have a whole lot of drugs there that didn't even exist. The whole class of drugs didn't exist when I studied medicine, right? And they're available today. How do I know about them? What are the doses of them? What are the adverse side effects of them? We don't know. This is evolving. Every year there is 6 new drugs. I can't keep up. So this, I can give more accurate treatment for my patients, but be also accurate when they come back to say, okay, look for these 6 side effects because they're more common with these patients. Personalized care. So somebody who has got allergies to certain products, especially now, if you have egg allergies, you can't take some of the influenza vaccines, right? Because there is egg products in there. But how would a junior doctor know that there is egg products? They'll just go and do it. They were not going to ask egg allergies. But now, these things are not, you'll ask, are you allergic to influenza vaccine? I'm not. But they wouldn't ask for specifically egg allergy. So, imagine in the middle of Timbuktu where they don't have all this technology. So this is about gearing that up to say, okay, if you were to click influenza vaccine in that patient, it will light up and say, hey, listen, this person has got allergies to this. I don't think you should try this. Or if you chart a drug at a very higher dose, it'd say, hey, listen, I don't think you should try this because you don't require this much. Their kidney function is this or their weight is this. So giving them personalized care, which is specific to that individual rather than general, and improved access to care. Think about, so this technology now, one of the radiology ones has been installed in one of the islands in Thailand where there is no radiologist, right? But there is a lot of tuberculosis. So how does a normal doctor there do? They have access to radiology, which is like the X-ray. They can do an X-ray, but there's no one to read the X-rays. So now this technology can see there, okay, listen, these are the normal ones, get them out. These are the abnormal ones, send them to the specialist and start working on getting their tuberculosis treated. Because otherwise they have to wait for months for somebody else come from overseas. So the only way to access this island is by boat. Nobody's going to go there and work, So obviously this technology can improve access. Obviously this is a remote area, but also remote areas within Australia as well where we don't have access to some of these things. Okay, so some of the pitfalls and considerations. So data privacy and security. We are opening a whole lot of healthcare information. You know what happened with Medibank information, a year or two ago. There has to be very strict protocols in terms of how do we use I'm going a little bit deep here. Do we use a closed system or an open system? So for example, in Gold Coast, we're using a closed system. So we use the technology to advantage to us, but our information doesn't leave our system, right? So it's very important. So all of our chat GPT and stuff, nothing is for free. They're taking our data. So when we are using, so that's an open system. All our information is going through them. But what we use within healthcare is a closed system. So, looking at data privacy and security is a very, very important feature here because we don't want information to be released and used for any other purposes. Bias within the data, that's quite important. So the data that is used to develop the model has to be configured to the population that you're using. So if I took African American population and their X-rays and use that technology in an Indian population, it might work, but it's very likely it won't, right? The probability of working accurately, so the accuracy reduced, okay? You don't want to be doing that. So because at the end of the day, if you're relying on a technology to do certain things for you, you want to make sure that the model that you're using does not have the inherent biases within it that is going to just perpetuate. So for example, an X-ray model that does not look for for example, a blood clot, and you're using that to look for a blood clot, it's never going to look for it because it was not meant to. And if you keep, then you will say, oh, there's no blood clot, no blood clot, no blood clot, but actually there is blood clots in some of them. It might be right in certain because it didn't see and it didn't exist, but that doesn't mean it doesn't exist in every single patient. Trust and transparency. So in healthcare, we always want it to explain to us. That's why, we don't want the report. We want the X-ray to be highlighted to say, this is where the error is, or this is where the abnormality is. So it's explainable, so we can understand why it made that decision. We don't want it to just say it and we just acting on it. We want it to be explaining to us. So for example, if the dose is reduced of a certain medication, why is it reduced? Because of the kidney function or because of the weight or because of X, Y, and Z. And there's a lot of regulatory challenges, especially within Australia. Even if you have the best product that works well, you have all the red tape that you have to go through, and it's an enormous task, and that sometimes pushes the prices of these technologies significantly high. So that's something that to be considered. So what I do when because there's so many applications, I get an email like 10 a day. I've got a really good AI tool you can use in your hospital. So how do I look at it? So I look at it, okay, is it, I don't want to do it for the sake of it. I want to make sure it's benefiting my patients. If it's not beneficial to my patients, is it good for my staff? Something that will help my staff, like the technology of typing. It will help with training, education, or professional development. Will it help my division, which is the division of medicine or stuff, or will it help the organization? If it doesn't meet any of these, we don't do it. Even though it might be the cheapest technology available, or it might be the flashiest thing where the minister can come and come and get the red tape, we don't want to do that. Next slide. So practical use cases. So I'll give you 5 use cases that you can probably go home and use it today. Okay. So the very first one, has anybody heard of Speaker Coach? Okay, so this is like my PowerPoint that I did today. If you go to the slide presentation section of the PowerPoint, there's something called Speaker Coach, and if you put it on, it actually starts giving you feedback. I'll present it to my device, and it will start telling me if I'm posing too much, if I'm going too fast, if I'm saying or something like that. It'll start giving me feedback, so I can improve on this is what we did when we were young. To go to a teacher and present in front of but now technology can give us that feedback. So that's one. Healthily is a symptom checker. This is developed by the doctors. So if you have any particular symptom, this is a free website. You can go on Healthily, put in your symptoms as free text, and it will guide through a series of questions. It takes probably about 5 to 7 minutes, but comes to a deductive sort of reasoning to tell you, okay, these are the 2 possible or 3 possible diagnoses and what you should be doing. So instead, you got a runny nose or whatever, say don't go to the emergency. You can probably, it's viral and you can just chill out today and, take some ibuprofen, you'll be fine. But if you got a headache with fevers and you're confused and stuff, say, hey, take you to the emergency, So it's good for people because some people say, I think I'm okay, or some people might just go for a toenail, to the emergency. So it helps. Resume builder. So, we have really good talent sometimes, but they're not able to project themselves, for jobs. And the reason for that is they don't know how to write a resume. They are very good in the skill that they obtain. They became a doctor or an engineer or whatever the case may be, but they haven't got the skills to present themselves. And resume is the first thing that goes, right? Like that's your face right in front of so Teal, which there is paid versions as well, but I'm not promoting any of these. This is just an example. So Teal is one good one where you can insert information, but it also gives you ideas to say, okay, you haven't put this. You haven't put your strong points. You haven't spoken about your communication, which is going to be a good skill in this sort of thing. So put that in. The next one is interview warm-up by Google. So how many times we want to practice an interview looking for someone, but now Google has developed a technology where actually you can do sort of a mock interview, with Google warm-up. And ChatGPT. Okay, I didn't want to leave this one out, okay? So lots of things. I'm going to Paris. I want a good itinerary for 3 days with children. It will give you an itinerary. If you want to do a marketing plan, business plan, if you want to do proofread some of your writing for grammatical punctuation stuff, you can do a hell lot of things. So I don't want to leave it out. It's a huge resource available for free. All right. Okay. I'll end here. So why is there a pothole? Why is there a pothole? Any ideas in a presentation with AI? Any ideas? Huh? Manually has to be fixed. Yeah, that's a good one. Yeah. So say that again.
It stops you when you practice.
Yes. Yeah, that's true. Yeah. Okay. Don't follow blindly. Okay. Good ideas. Okay. So reason I had this here is so a few years ago, Moreton Bay Council had a big issue. They had some 17,000 or something potholes to be fixed, but they didn't know how many existed. And there was after floods, so everyone was blaming the council. You guys are just too slow. But the thing is, like, there's a whole process, right? The process is we need to find out where the pothole is. We got to mark it up, like, how big it is. What do we need to do that? Generate a work order. Get the people, technicians, to go out there and fix it. So it's a 5-step process. But what they came up with a brilliant idea, and you can Google this up. I'm not making this up, right? They said, okay, why don't we put cameras in the garbage bins that go around every area of the council every week anyways, and use all the pictures that are coming through and find out how many potholes are there in the whole council. And that technology will count all the potholes, see how many potholes are there, what size, generates a work order for that area. So the only thing left is to go and fix the potholes. So now they are doing the New South Wales as well. So Moreton Bay City Council was the first one, to do that. So just wanted to end it on a fun fact. Yeah. All right. Thank you.
What a brilliant talk. Thank you. Thank you, both Dr. Sattar and Dr. Salim. Doctor, I might ask you guys to come up in the front here and put a couple of chairs for both of you. Maybe, I'm pretty sure there's plenty of questions everyone would like to engage with you all. You've held them back a little bit through the process.
Very question you have. So how are you decided
All right, we just open the floors, keep it short, give the speakers the time to respond. Anyone open up with a question? Wasim bhai?
How are you guys going to integrate your waiting list with your AI? Waiting list.
Yeah, so we're working on it right now. So right now, the waiting list is just a number. So we know like 300 patients at IBD CNA or 400 patients in a lung clinic. We don't know what stage of the disease they're at. So we are trying to work on a solution that, first of all, the information needs to come in a text form that we can extract the information from using NLP, natural language processing, and then categorize those patients into different categories. So some patients who we don't need to see, because they can be managed through their general practitioner, we start sending them advice. So that they're not waiting for 6 months only to be told, okay, take some Panadol and go home. We could have told them 6 months ago, right? Or we can't do anything for you. So we want to try and work on those things. So critical ones that come on the top. Then the second category will be the ones we'll see that within 6 months. The third category will be like, can you go back to your GP and manage it? This is the advice. And if it doesn't get better, come back to us. So there will be a memory of that patient. If the patient falls back again, then we see them. So we're working on that, but that's sometime to come.
Add something here. I think the key idea is that how to optimize the resources and use them efficiently. So one of my PhD students is quite relevant, working with the Cyrus Health Center to predicting surgery time. So each surgeon, you have one theatre available, and how efficiently you can use that resource. So that will have some impact on the waiting list. So if you more efficiently you can use resources, and AI can help because it has the knowledge, data over the time, who is using, what kind of procedures being held, so it can optimally help them. Of course, I think prioritization in other ways, but you are right.
Salim bhai, I have a question in terms of, you touched on the legislation side and the privacy side. Sattar bhai, with your work that you're doing in the university and working with CSIRO, how are you working with the government departments to make sure that they keep up with the legislation side of things? For example, the Privacy Act that we talk about in the industry is from 1998, which has been tweaked a little bit. So how do we keep up with this?
Well, I think, we are the professors, we just speak and criticize people, So we don't really engage in terms of the legislation, but we do have issues. Our job is to raising the issues. If something is breaching the people's privacy, and there are more than 12 agencies in Australia. Data breach is a big thing. Cyber security is a buzzword nowadays, and I'm teaching this course this time. And what I learned is a common sense. The people should be approached. If something happened, why it happened. They go to all different procedures. But in my academic career, I think we just raise the big issues, like ethical issues, and from moral philosophy point of view, and from legal point of view, I was talking to some people Like if you build something in America and something in Australia or Japan, they're two different protocols. People,
Yeah,
they
absolutely.
may not allow you,
Absolutely.
Regulations are depends on the different countries.
Yeah.
Some countries are too liberal, like Europeans are very conservative. So again, I think it's beyond our control. And that's why
Maybe a follow-up question for you, Dr. Salim, is what are the things you look at when you're sourcing an application like that? What you looked at, for example, as simple as something that scribes for you. What are those privacy checks that you make, or the legislative check you make, so you don't get into those?
So legislatively, there is not much, to be honest, in that scribe space as such. There is usually when it touches into clinical decision support, that's when your EGA, we have the therapeutics and administration, that comes into play, that EGA approved. But most of the other applications they don't require EGA approval. So when we look at sort of some of these technologies, what first we look, as I said, the layers that I said, do we really want to do this and why we want to do this? Is it good for our patients, staff, teaching? Like, we don't want to do it for the sake of it. That's the first thing. Second one is, if you are using data, where is data going to source? So most of these things are on cloud now. Is the cloud within the Australian context, or is it going? So the reason we chose Lyrebird as opposed to some of the other ones, because some of them had clouds outside in Asia, in European countries. We didn't want to leave the data outside of the Australian borders.
Yeah.
So that is the second check. The third check is penetration tests. Obviously that's more technically advanced, but it's about, we do 6 monthly or 12 monthly penetration tests. We also ask the vendor who's selling the technology to say, tell us how are you doing the penetration test and the results of that. So we have the whole set of technical experts with us who work with me, go through all of these things. And obviously now I just sign off and do things for them. So they'll do all the reports and they'll submit it to me, and then obviously we process accordingly. Yeah. But data privacy wise, not leaving the context and what's the data penetration tests and stuff, those are very important.
Excellent.
Do you have to take the consent of the patient before using the Lyrebird, or you can use it for everyone?
No. So as you saw, like when I first started talking to the team, the first pop-up was consent. If they don't consent, we don't use that. And that consent gets recorded again with AI at the bottom of the notes. It was consented.
So basically, how frequently you are promoting this kind of
guys?
No, especially this AI, for the other doctors, So you think that, as you said, that this is sort of what I understand, it's confined to those hospital. So
yeah.
I mean, actually, it's so beneficial. I can see. So you think that you guys are given this liberty to go to other hospital and promote this
the
thing?
Queensland health framework is very different. The funding is only for one hospital. So that's the problem. So Queensland Health, which is funded by the state, whereas the GP practice funded by Medicare, which is federal. So and they are private businesses. Queensland Health is a government employee, so we got a little more freedom, especially under the previous government. We had a bit more budget to do some of this.
Dr. Salim, just a follow-up question on that.
Yes.
Is that just exclusive to Gold Coast Hospital, or other hospitals also sort of implementing these technologies?
So the AI within endoscopies is becoming widely available because it's become much cheaper now. So as it becomes more cheaper, I think people are getting, and secondly is also the comfort. So X-ray, for example, private X-ray providers are using it for probably last 2-3 years. In the public sector is coming now. I think once 2 hospitals do it and the price goes down, it will easily be adopted by everybody else, because there is no evidence right now, like how to implement it, how to safely implement it, how do you manage it? Because a hospital like Mackay or Vanderbilt, they don't have the resources like what I have. So I can develop the evidence, develop the fundamentals, and then say, what, there you go, you can use it. So we are working with Department of Health to say, if you fund partially, so we currently have a couple of other ARC and other grants that we applied to the university to collaborate and publish this data. So that way we can then make it available not just to Queensland but across the country. They can use it.
One more for Professor Sattar. Like the technology used in medical field, what Dr. Salim has been talking about, which are the other areas where AI has been extensively used? Which are the other professions where AI is being
So I think this is everywhere, like in the legal systems, for example. This is a application of generative AI. Everywhere you can see that. Every company, when there's a commercial companies, like I don't know if a specific example, but the legal contract generation is the one application I can see people are using it. Like if you want a small contract to be written, immediately come up and just you have to check and sign. So this is one good application. And in the regulation terms, I forgot, I think nowadays as academics, one regulation we have to follow is that our collaborations with the internationally has to be complied. We have to fill up the several forms, like whether somebody can sanction countries or something like that. So I think it's a different opinions. In my opinion, it doesn't help much, but all the governments are becoming very aware of this thing. People should not steal these sensitive technologies, and especially I think in certain countries. Yes,
Is this technology just being used in the emergency department or it's throughout the whole hospital?
Throughout the hospital. So in terms of examples where it's been used, so two that we are exploring in the hospital is inventory management. How many drugs are there? How many equipment are there? We have this one person going every day counting. So now these computer visions, there's basically sort of one small this GoPro kind of camera that goes through once every 24 hours and just tells you this is your inventory today, and that's pretty much it. So if you order,
place the order as well?
Not yet. So we are first developing the technology where we can just screen, and then secondly, then obviously what our needs are, and then it can generate a work order of some nature to say, okay, you need this many drugs and these are the quantities. Then the person can just make sure that this what is necessary and hit the button and it go. So yes, so that's the inventory management. The other one we are seeing used now is in some of the far north or remote areas where there is huge forest, and to control vegetation, they usually do burns and everything. So now they're using drones with cameras. We can take pictures and tell you where there's extra vegetation, so they can control the fire. Previously, somebody has to, the rangers have to go in and document that whole geography, come back to the base, report it. Now the technology is available, so you can tell, okay, you need these many burns in these many months, do it and move on.
So they are of infrared, yeah? Yeah, infrared.
I'm gonna take a question from the back.
There is experiments being done, but I don't think we have designed yet anything that has been used. Yeah.
Just the gentleman at the back there.
If AI was to misdiagnose a patient, and a doctor made decisions based on those findings that the AI made, who would be responsible for this findings?
Yeah, so this is a huge question that comes to me like all the time, because probably I'm the one selling it to all the doctors out there. So the question is, so again, don't be scared after this, okay? So the question is, how many times do we misdiagnose as humans? Do we know what percentage? 20% of the times. So this was done by one of the studies where they said, okay, these are the death certificate, this was the cause of death listed on the death certificate, and they did autopsies on all the patients. 80% was right, 20% was wrong. 20% of the time doctor got it wrong, and that's it, not about the diagnosis. Diagnosis of death. And like, what did you die of? So that's where we derive like 20%. So we need to hold AI to the same standard as a human being, not superior. So we don't want perfection. We want it to perform the same sensitivity and accuracy as possibly a human being. So that's what we did with the node generation. So what we did, so our research is going to publish very soon, is we collected notes which were done by the doctors, and they didn't know we were using AI. And the AI also made notes. And we compared it, and AI notes were much better in accuracy, but also in correctness. The doctor sometimes forgot about the allergy or that exposure to a particular drug, but AI picked it up because it was listening all the time. Whereas human might have a brain fade moment or whatever, and they recognize. So to answer specifically, you'll still be the doctor, because at the end of the day, it's an assistive tool, not something that is going to replace us. And I was expecting that question. Is it ever going to replace humans? It's not going to replace. It's about the way we work, our workflows, our work practices will change. Right? It won't change. Like it won't take over all of us because it's quite cognitively. So we I think what I see is like we won't be seeing humans collect when you go to Woolworths and there's somebody looking at the order and keeping one pack of chips. That won't happen. It will be happening there. You will come and pick up your order, but it will be done through a machine that has got AI within it and picks up all this and makes your parcel. But we'll be doing a lot more intelligent work that requires a lot of cognitive.
So
I have a follow-up question.
yeah, one thing I like to respond. Is it okay?
Yeah.
I think a few decades ago there was a debate about strong AI versus weak AI, and there was a fiction novel by Penrose or who have written, I think, this one, and very scary about AI. And still people are like thinking whether AI is going to replace human beings, So when your question comes about the AI systems diagnosis versus human beings diagnosis, so one big the flaws right now, like trust or explainability. Eventually, what as a scientist we are doing is coming up with some commonly agreed approach, like maybe statistically founded confidence in particular outcome decisions that are acceptable. But again, the mathematically 100% accuracy cannot be guaranteed. That's I told you about what abductive process is. Abduction. All diagnoses are abductive reasoning. You cannot guarantee. But at the human level confidence, the people are working in different ways, like statistical evidence to establish how much confidence you have in particular. It's not today. Even 80s, there was a Menon system. It's a rule-based, like Menon system used to advise people like what diagnosis and monitoring these things. And they used to use some certainty factors, arbitrary numbers. Some experts say it is about 70%, so use the 70.7 for that, 0.3 for that. That was very subjective numbers used to come and then they calculate the overall confidence. So I think it is gradually, my view, I don't know how strongly, but AI is still not going to replace the human beings. It will become the great assistive tools. So the ChatGPT's text is just like symbols. It is a meaning as a human being you assign to them. That is more important. The semantics. And semantics is relating those symbols with your intended interpretation, what you have, the doctor or patient, how you interpret those symbols. So for AI system, these are the strings, So the meaning is the experts or human beings have to assign them. Sorry, I think I...
No, that's all.
So if it's not replacing the AI and making humans less intelligent by reducing their critical thinking or problem solving skills.
Well, yeah, I think you are right in the way, the philosophical question, because since we started using the smart calculators, we forgot to use log tables. Okay, so there will be side effects.
The human race, just giving an example. 50 years ago, I wasn't even born, but the car's batteries, like car batteries. Now the car battery comes with a tag, please do not blink. So, regardless of AI, I think humans are becoming close to what they were, regardless of AI. I think the importance of critical thinking will always exist, because I think AI is not the be all and end all. It's going to be something more superior. We didn't know AI would exist 20 years ago, in the form that it does. So I think that critical thinking will continue. I think the work that is menial and done constantly and we're paying a lot for it will reduce. So you will be forced to do critical thinking. That's how I'm thinking. Because right now, I as a doctor, have to do a lot of menial tasks in 40 to 50% of my time. Typing notes and writing a letter and posting that letter. If I can take that away, I can now start critically thinking that this patient who I can't diagnose for the last 5 years, what could it be? I can put my thought now. So the way I feel within healthcare is actually going to give me more time to do critical thinking.
Yeah.
But everybody is different, right? again, that battery thing, it reminds me. Yeah.
I think I may take one more question from the floor there.
Professor Sattar, your suggestion that only it's EU that has got regulations in the world control the development of AI.
EU was the first to enact the law.
So the other countries don't have.
Yeah, I think now they are catching up. They are. I don't know in the what stage up to date. No, I don't have up to date knowledge. But even Australia have now law, and they are following on the same line. There's laws about data breach and now AI systems. I
Could
think.
there be rogue developers that can be making things that can go in the wrong way?
Yeah. Well, I think I don't know. I think, but you have to check the details of. I haven't gone through the every details, but it's a software, like software flying aeroplanes nowadays, and like who will be legally responsible if some accidents happens, So the AI is not like a magic word. It is a kind of a software program written by human beings. Okay, that is making machines behave in certain ways, and so I don't know. I think whether
Can it reach a level where machines think on their own and work independently, like we used to see in science fiction movies? Robots taking over.
Yes, there is the interesting book Killer Robots, my friend, and singularity is a fear. I think that's what I call fear, and I'm not in the fear camp. I think there are a lot of promises. I think a lot of interesting problems which we don't understand. So it can improve the human understanding of a lot of challenges we have, like about the life, for example, about understanding the universe, understanding what exists beyond this solar system. So without these technologies and advances, we can't progress our knowledge. That's the fundamental, I think, and everybody agrees on that. How we use it is a different story, Like now the flying machines are becoming like killing machines. You can sitting in your lounge and you can direct to kill people, So that is the abuse of the technology.
Absolutely. Absolutely. I think a famous saying in the Silicon Valley from the NVIDIA CEO is, to your question, people are not going to lose job to AI. People are going to lose job to people that are using AI. Is what the big famous saying is. So with that, I'm going to hand it over to Amin to just give us a vote of thanks and thank our speakers as well. Thank you.
On behalf of Crescent AusIndia, I would sincerely thank both the speakers, Dr. Abdul Sattar and Dr. Salim Menon, for taking their time out and delivering such a interesting and engaging session. So, and also thank you all for attending today, and give both of them a big round of applause. And maybe you can help yourself with some of the snacks while you're on way back.
Thank you, everyone.
Thank you.